All right, this is a very useful skill that I'm going to teach you guys right now. How to find contours, how to create contours in GIS, then export contours into a 3D program such as Rhino, and then also how to take those contours and create a 3D surface on that so you can create site models in 30 minutes. So the website you need to go to for this is this website called nationalmapviewer.gov right here. And everything's going to be recorded, so you don't need to remember this, but if you want to write it down, you can. This is the website you need to go to get contour information for pretty much anywhere in the world. So, anywhere you want to get contours for, any suggestions? Any thoughts?
Sure. The site right south of the Arch Grounds.
Great. All right, let's do it. Because that's your studio site, right?
Yeah.
Yeah, that's great. All right. Here-ish?
Yeah.
Okay. So what you want to do is you want to click on this thing called Elevation Products right here. This will give you access to what's known as a DEM, a digital elevation model. A digital elevation model is basically pure elevation data that you can use to get contours for sites. You always want to go for something that's a high resolution, which is like a 1/3 arcsecond or a 1/9 arcsecond. These are two ones you want to use. Never use anything else because it's going to be too blurry and not worth it. I would highly recommend 1/9 if you can find it. So I click on this availability button here, and I can see like this area here has good 1/9 arcsecond information. So I'm going to just click on this, check this box here. Then you want to do is you want to draw a box around the site that you want information for. So this is your site, right? Basically, is that about right? Okay. So then you click on Find Products, and then you have two options here. This option here, if I click on Footprint or Thumbnail, sorry, it shows you that it gives you contour information for this entire area here. So this is what I want. I want to download this IMG file here. So all I do is I click on Download, and it downloads this this image file. So it's going to take a minute to download. I'm just going to pause. So in GIS, I'm going to start blank map. I go to Templates. I go to blank map here. You're always going to add, I would say, a base file first, so you can orient yourself. So I'm not going to show you how to find shapefile information. I'm just going to use some shapefile information I already have on hand for St. Louis. That's a whole nother tutorial. So let's just do, for instance, let's see, a road layer here, like this. So this is just a road map of St. Louis. Every time you have information in GIS, you always want to make sure that your coordinate system is chosen correctly. So the way you do that is you double click on this layers button here, and there's a coordinate system tab right here. For Missouri, which is the state that you're working in right now, you always want to use the NAD 1983 State Plane Missouri East feet, this one right here. Again, I'm going fast because it's all being recorded right now, so you don't have to remember it. Just watch it again.
Are you recording?
Yes, it is. That's why, let me just pause it real quick. Okay, so this is the coordinate system you always want to use for Missouri. If you're working in a different state or anything like that, you just search for the state that you want to work in. So I'll search for Missouri in this line here, and you want to go to projected coordinate systems in state plane, and you have all these NAD coordinate systems here. And you want to use this one, NAD 1983 feet, and then we are in Missouri East because we are in the eastern half of Missouri, right? Makes perfect sense. So you just double click on that guy, click OK, click OK. This was already set to the correct coordinate system, so it doesn't move, right? So now our download should be done. So I'm just gonna take that guy, I'm gonna extract that zip file that we had here, and then I'm gonna find that zip file here. I'm just going to move it to my desktop for now. If I go in here, you see that there's a bunch of files here that represent a DEM image here. So back in GIS, you want to find a way to bring that information into here, and the way you do that is use the ARC catalog. The ARC catalog is this little yellow button right here in this corner here. If you click on that guy, just pause through. If you go to ARC catalog, this is basically a browser that you can use to bring information from anywhere on your computer into GIS. So I already have a folder connection for my desktop set up, but I'm going to remove this right now, this connect folder. To add a folder to your catalog, you want to click on this button right here called Connect to Folder, like so. And then you click on the area that you want to bring in information from. So in this case, I saved the map on my desktop, so I'm just going to click on my desktop as a folder to use, click OK, and then that brings that information here. And then this is the folder that had the DEM image in it. So I'm just going to take this guy here and I'm going to drag it into the map here. And so this is the contour information brought into GIS using the correct coordinate system. All right, so what you do is you zoom into the area that you need site information for. The smaller the area, the better the results, because you're not going to be cutting contours for the entire city, so to speak. So what you want to do is you want to use what's known as the 3D Analyst extension. So if you don't have that enabled, you want to go to Customize, Extensions. You just want to make sure that 3D Analyst is checked here before you do anything else. You can use 3D Analyst, or you can also use Spatial Analyst as well. They both function the same way. So you want to go to what's known as the Arc Toolbox, which is this little red button up here. If you click on that, you bring up all these tools that you can use to cut contours. Is this new to people, or some guys know this? Okay, great. So in 3D Analyst, you can go to what's known as raster surface and contour right here. Raster surface is any piece of information that has a raster data set. This DEM is a raster data set. So you can cut contours of raster data sets. So I'm going to double click on contour here. And you're going to input this file here into that, like so. I just dragged it into the first line here. It's taking a second. I just leave this first line unchanged. It just saves into a default geodatabase. That's a whole nother topic. We're not even going to get into it. It's not part of this class. Contour interval is what is the spacing between the contours, 1 foot, 2 foot, 3 foot contour intervals. Typically, you want to do 1 foot contour intervals because that's the most detailed you can use. So you type in 1. Base contour should be 0. Z factor, this is important because you got to understand what unit you're working in. DEMs are always in meters. And typically in studio and that kind of thing, and actually in professional practice, contours are in feet, right? In the United States. So you need to apply the conversion factor of meters to feet, which is, just remember this number, or if you don't remember this number, just remember the video. It's 3.2808, right? So 3.28084 is the actual conversion unit from meters to feet. There are 3.28 feet in a meter. And then what you want to do is you want to click on this environments button here. You want to go to what's known as processing extent and check that line here, and then click on same as display, like so. What this does, it basically means that when I cut contours, it's only cutting contours that are within the window that is being shown right here. If you don't click this option, it's going to cut contours for the entire data set. So I click OK. I'll click OK. Now it's just going to think about it for a second. I'll just give it a second to think about it. It's happening. It's happening. I know it's happening. Don't worry. It's happening. There it is. Okay. So if you right click on this layer here and click on the attribute table, which is basically the data that is embedded within each shape, you have this line called contour here. This is the elevation above sea level. That is useful to know. So if you're doing flood studies and that kind of stuff, you have this number to work with. Now this number here can be visualized in GIS by double clicking on this and going to the symbology and quantities, and then clicking on contour as a value, and then clicking apply. So you can visualize high points and low points, and you can increase the number of breaks in it to increase, say, the gradient here. So this is a really cool graphic. But now you want to understand how to bring this information into a 3D modeling program where you want to build site models, right? So, so super fast. What you need to do is you need to edit the attribute table to make it a table that is legible within a 3D vector program such as GIS, or it's not GIS, Rhino or AutoCAD. So what you want to do is you want to do something called add field. This is make no sense to anyone. Again, it's just all this weird stuff that you just needed to go through just to get the results that you need. So click on add field, and you want to use a number called elevation, right? And you want to set this elevation as a double. I'm not going to explain why. There's a long explanation why double is it. Basically, a double means a very, very precise number. That's all. Don't even question it. Just listen to me. So click OK. Elevation here. Then what I want to do is I want to bring this contour number into the elevation field. So all I do is just right-click on elevation, go to field calculator, then elevation in this box here, elevation equals contour. I'm just going to double-click on this to bring that here. Click OK. And then that number copies over to this line here. So what this means is when I export this to CAD, this contour line will have that elevation as its Z value, which is very good, which is very, very nice. All right. So you see that's our map here. So now let's export this into a CAD format. So you right click on this layer here, go to data, export to CAD, right? So now that data set is in the export to CAD here. So we have it set as a DWG, which is the AutoCAD format. Then you set a location for this output. So this output will be on, say, just saving our desktop for now. So I'll just click on this folder and we'll just save it on our desktop. And we'll just call this one contour riverfront. And then the next important thing is you want to go to this environments tab here and you want to click on output coordinates, same as display, because what this does is it inherits the coordinate system that you set previously. This is important because we want the units to be consistent across every level of this export, feet. So our contour interval is in feet, our coordinate system will be in feet, and then also the cartography will be in feet. So I click same as display here because that basically inherits the coordinate system that's within the data frame. So I do those two things, I click OK, then just let that thing export to CAD. Okay, then it has exported the CAD, it added a new layer here. I don't need that layer here anymore. We're done in GIS. Now, you go to a 3D program such as Rhino, for instance. Let's just open another, I'll just do this. This is another thing I wanted to show, but I'll show this next week. I'll just make a new file. So you want to use a model template that's in feet to start with, right? So I'm going to click on this large objects, feet. And then we're going to import this file here, the contour riverfront that we just exported. Oops. Okay. So you see what happened is it basically took the contour layer here and it brings it into a 3D program such as Rhino, and see it has all the elevation data built into it. So for instance, you can see the arch grounds right here. These are the contours here. As you can see, contours close on themselves. They always indicate some kind of berm or depression or valley. So this is the top of that. This is the bottom of that. Let's make these black or something. Okay, so now you want to build a site model, right? For renderings and whatever you need to do. So the way you take these contours and you construct a site model from this, I only know one way to do this, and it's my favorite way of doing it, and it's using a Grasshopper script. So this is where the Grasshopper comes into it. And I'm just going to write the script really fast, and when you watch the video, just follow along and write it again, and you'll learn. So open Grasshopper. You get Grasshopper, you can just type in Grasshopper right here to bring it up. And I'll create a new document. So the first thing we need to do, we need to do a few things to set this up. What we need to do is we need to create an area of intervention. So I'm going to create a layer called bounding box. And in this layer here, I'm going to create a rectangle. This rectangle is going to be the area that I want to build a site model for. So let's just make it, say, something like that. The other thing I'll have to mention as well is that you need to have information for the entire extent of this box here. You see how there is no contours here? This will create an error in this thing. So an easy way just to get this figured out is I just, for instance, take one of the lines on the edge here and I just kind of copy it over and just copy it over like that, just so that when I create a mesh from this, it kind of interpolates in between the two lines here. You always want to have information in the entire window of this bounding box here. So in Grasshopper is a very complicated program. So in Grasshopper, I pull in a curve parameter right here, like here. I just click on this button here, curve, or I just double click in the Grasshopper window and I type in curve, right? You right click on that component and you click on set multiple curves. So now it's going to ask you to set curves in Rhino. So I'm just going to right click on the layer that the contours are on, which is this one here. And then click select object, so it selects just the contours. I hit enter on my keyboard, and now those contours now have been successfully brought into Rhino. Now I want to bring the second piece of information, which is the bounding box. So I right click on this guy here, set one curve, because there's only one curve here. Click on that box there. And now that box is now set in Grasshopper. I can turn off these layers in Rhino because that keeps it so you don't accidentally move anything or do anything else. So this is your contour line, this is your box line. We want to take these contours and we want to turn that into a mesh. The easiest way to do that is to type in explode. I'm just double clicking in the environment and typing in the function I want. Type in explode, plug this curve into the C one here, and that basically takes this layer of contours and it turns it into its vertices. Basically, every polyline is made up of control points or vertices. And these control points I can use to create a mesh. So I take the V here, which is the vertices, I flatten that. Too much stuff to understand, don't worry about it. This is why you don't have to remember this junk. Just follow what I'm doing. I right click on this, I click on flatten, and then I type in this thing, and I can email this script to you guys as well, so you don't have to even like remember how to write it. I click on this thing called Delani mesh here, and then use this here to plug into this P here, and that creates a mesh that is generated from these points. So just give that a second and it thinks about it. So you can see that this is the result of that analysis is a mesh. If I turn off the preview of this, you can see it's a mesh of that terrain. That's not enough. We want to turn this into a format that you can actually use in Rhino. And also you see why I built that. I put that contour, I just copy that contour over here so that the mesh extends within the entire rectangle here. If you did not pull that over, there would be a large gap of white here that did not have any information. Okay, this next part is going to get even more fun. So we're going to take this rectangle here and we're going to divide this into a series of gridded points. And the way you do that is you do the divide surface command here. And the reason I do this is because I want to turn this mesh into a surface, because in Rhino, Rhino likes surfaces, it does not like meshes. Meshes are a bit too hard to work with. Surfaces are much nicer to work with. So we want to convert this mesh into a surface. These points here I'm going to project onto this mesh vertically so that it creates a new grid of spot elevations. So the denser this mesh here, this grid of points is, the better the result will be. So for now, I'll just do something like 100 by 100. So I'm going to pull it down a panel here. I just click on this little panel here, and I'm going to double click in there and add 100 by 100 in here. You can make this as dense as you want. You can make it 200 by 200, make it 300 by 300. Just know that the denser it is, the longer it's going to take, right? So these are just 100 by 100 grid of points. We're going to take these points and we're going to use this function called mesh array. I'm just double clicking and typing in mesh array. What this does is it allows me to take this mesh here and interpolate the intersection of a grid of points onto that mesh. So I'm going to take this grid of points here, plug into the point line here, then I'm going to double click and type in Z. Z because Z, X, Y, Z, Z is the vertical direction, right? I just double click and type in Z. So you plug that into this D component here, and you see what happens is it's going to be great. It's going to be magic. Just give it a second to think about it. And see what happens is all those points now projected onto that mesh. Where's my Grasshopper window? There it is. So I'm going to turn off preview for all this other stuff because we're almost done. We just take these grid of points here, right? And now we want to use a component called surf from points, right here, surface from points. So you can take these points in here, you can plug it into here, and you can create a surface. So what you do is you take this X here, which is the intersection points, you flatten that list, you plug that into P. U is this U number right here. You see 100 plugs into U here. So I'll plug in that same number. I'll just drag the little thing in here like that to U. It turned red. Why did it turn red? I'm not going to explain why. It takes too long. The way you fix this is you right click on U, you go to expression editor, you type in X plus 1 because we need to add one more point in order to fix the U value. Not important. Has nothing to do with grading at all. This is just what you gotta do. Click OK, you have a surface, and then you create a new layer here. Call this one surface. Make sure that's set as your current layer, then As this is selected and turns green, you right click on the space and click on bake. And that's it. So I can go to like a shaded view here. You can see that is your surface created in Rhino. And as you can see, it matches with the contours really well. You can use this to build site models, you can use it to do renderings, you can use this to do anything you need to have a basic site condition. Put your design on top of this mesh here. And that's it. And that, students, is how you survive grad school and not waste time building site models in the computer. Do it fast, do it this way, it will save you a ton of time. So with that, I'm going to